Today we're going to be factoring trinomials when a equals 1. So this means that we're looking at a quadratic in standard form, which is ax squared plus bx plus c. So all of the questions today are going to have an a value here of 1, a leading coefficient of 1. So what does factoring mean? Factoring is undistributing, is what I like to call it. So normally we would give you a question where you have to multiply them together in order to create this. Okay, you would be multiplying two binomials together, something that looked like this, in order to produce this here. Okay, so x squared plus 7x plus 12. Well, when we're distributing, when we're taking this term times this term, that's going to have to give us x squared. So how are we going to do that? Well, x times x would give us x squared. For these back two terms, we know that these back two terms are going to have to multiply to give us the 12. So we need two things that are going to multiply to give us 12. Now, the middle term here, this 7, if we were to actually distribute these together, so x times x would give us x squared. And then we would have x times something would give us some number x. And this, we would also distribute this term, whatever it is, to x. So again, we would have something x. So those two things we need to add together to give us a positive 7. So we need to satisfy both of these requirements in order to figure out what numbers go here. And it's got to be the same numbers for both of these. So if we're thinking numbers that multiply to give us 12, so we have 1 and 12, 2 and 6, 3 and 4. Which of those are going to add to give us 7? Well, 3 times 4 is 12, and 3 plus 4 is 7. So that means that we would need a positive 3 and a positive 4. And then once we have this, we can check our answer, okay? So x times x is x squared. X times 4 is 4x. 3 times x is 3x. And 3 times 4 is 12. So when we combine like terms with this, x squared plus 7x plus 12, it gave us the original question, so we know it checks. All right, so remember with these questions, you should be able to tell me if you're 100% correct or not, because if you multiply your answer together, you should get the original question. If you don't, you did something wrong, either in the factoring or in the checking, okay? So let's take a look at this one. We have d squared minus 4d plus 3. So since it says to factor and there is no GCF at all, we're going to put our parentheses. To get d squared, we know that we need d and d. All right, these back two spaces need to multiply to give us 3. So we need two terms that multiply to give us 3. And then the middle terms, when we do that distribution, we need to add together to give us a negative 4. So our only numbers to multiply to give us 3 are 1 and 3. So we know it's got to be 1 and 3. But if I use a positive 1 times a positive 3, that does give me a positive 3. Positive 1 plus positive 3 does not give me negative 4. So that doesn't mean that we can't do this. How can we change this? Well, a negative 1 times a negative 3 is a positive 3, and a negative 1 plus a negative 3 is a negative 4. So both of these here would be negative. So let's double check this one as well. So d times d is d squared. D times negative 3 is negative 3d. Negative 1 times d is negative d. And negative 1 times negative 3 is a positive 3. So if we combine those like terms in the middle, we get d squared minus 4d plus 3, and that is the original question, so it checks. Okay? This is the general process that we're going to be doing for all of these problems. All right, so here we have m squared plus 8m minus 20. So we know we need m and m, okay? And then we need to find two numbers, in this case, that multiply to give us negative 20 and add together to give us a positive 8. Now, there's nothing that says you have to write this stuff off to the side, but if it helps you, that's fine. If you're better with your math facts, or you can kind of keep track of it in your head, then you don't need to do so. All right, so our options for 20, 1 and 20 aren't going to give me 8 at all. 2 and 10, those could give me 8, or 4 and 5, which aren't going to work. So we know we need 2 and 10. Okay, but 2 plus 10 is an 8, and 2 times 10 isn't negative 20. So one of those numbers needs to be negative. So negative 2 times 10 is negative 20, and negative 2 plus 10 is a positive 8. So we would need a negative 2 and a positive 10. And then you don't even have to show your work for checking, but you should be checking. So m times m is m squared. M times 10 is 10m. Negative 2 times m is negative 2m. So when I combine those, I do get 8m. And negative 2 times 10 is a negative 20. So it checks out. What if we have p squared minus 3p minus 18? So we know that we need p and p. For this question, we need two numbers that multiply to give us negative 18 and add together to give us a negative 3. So you cannot ignore those signs that are in front of those terms. So thinking of all of our factors of 18, the ones that are going to be 3 spaces away from each other are going to be 3 and 6. But in order to make them be negative, one of our numbers needs to be negative. So that means that our 6 needs to be negative. So we need a p plus 3 and p minus 6. And when you multiply those together, you do get the original question. All right, last one here. 2x squared plus 10x plus 12. How does this one look different than what we've seen so far? Well, everything else had just a 1 in front of. So this was 1p squared, or 1m squared, or 1x squared, or 1 whatever. Well, now we have a 2 in front. But if we're looking at this, what do we notice about 2, 10, and 12? What we've talked about previously was looking for a GCF, so that's the first thing we're going to do here. They all have a 2 in common, and left hand side would be 2x squared plus 5x plus 6. Now that we have this, we're going to look to this inside piece to see if that can factor more. So we're ignoring the 2 right now. We need two numbers that multiply to give us positive 6 and add together to give us a positive 5. So we have 1 and 6, but those aren't going to give me a positive 5 or a positive 6. So we need 2 and 3. So this 2 will stay out front. We just carry that along. And then we need x plus 2 and an x plus 3. And that would be our answer. So to check something like this, I would multiply these two parentheses together first. Okay, that does give us x squared plus 5x plus 6, and then distribute the 2 back in. And that's it.